And hooray, we're now live. So you can say hello to the world out there, those of you that want to. And I'm going to quickly drop some things into the chat for us here. One is the live stream link. So if you want to make sure that people around the world, we got one in there, are seeing what's going on, here is our live stream. Additionally on that, I'm about to share some slides and make sure I got the right slides here. And I'm going to share the slides in the chat so you guys can follow along. Gotta get better at my copying and pasting there. At least we're not live. Oh wait, yes we are. All right, and there's my live slides. Now, let's let the presentation begin. Hello, I'm Thomas Hall, Executive Director of CleanStart, and I'd like to welcome you all to the CleanTech Meetup tonight. I also want to highlight those of you that supported us by purchasing a ticket for this CleanTech Meetup. It shows us that you're really interested in what we're doing and encourages us to continue. If you're a startup and you have an idea and want to bounce it off of us, connect with me through Calendly, my email, visit us on LinkedIn. If you want to connect with me on Calendly, I'm going to drink a link for coffee there. Connect with me and we'll see how we can help you out. Another place that's a great way to connect and start your clean tech idea is connecting with Sac State, specifically the College of Engineering and Computer Science. There they have faculty that can help you with a project and help you move your idea along. They also have the Carlson Center there with resources for startups. I actually see that we have, I think, some faculty in the audience tonight. I know, oh, there you go, Professor Zabihina, welcome. I also want to thank our CleanStart, our supporters, which is the Sac State Engineering and Computer Science Department, SMUD. There are people in the waiting room. SMUD, Weintraub Tobin, Blue Tech Valley, and people like you. And also we've been running a fundraising campaign. You've probably seen our emails, and I want to thank the people who have donated $500 to join our CleanStart Wall of Heroes: John Allen, Mike Bell of Symbio, John Jaggers, Grey Rock Energy, who they've fundraised a significant amount recently. So congratulations to them for making a big impact and supporting Sacramento as a clean tech hub through their innovation. Dan Kellen, Frederick Tornato, Jack Crawford, Mark Hinwood, and Evolution Accelerator. If you're an early stage company, check out Evolution Accelerator. They are taking applications soon. And if you want to be, since we're still in this fundraising campaign, if you're able to, please support us. You know, any donation helps. We've had a lot of support already. Our Patreon supporters, Mark Humber, Lynn Goldsmith, who I know is here, Peter Mackin, saw him in the audience. My dad, Guy Hall, thank you, Dad, for believing in me. Ryan Johnson, Brian Hoblet, Daniel Sperling, Ryan Barr, and Larry Kellerman, and the rest of the community that has donated. So tonight, I'm going to have some quick announcements, very quick. Then we're going to have guest presentations, about 10 minutes each, followed by a panel discussion led by Gary Simon. So, I should have proofread that. But welcome and join us for more of these in 2020. We're going to have meetups on the ARB's funding wizard, more discussions on storage, glass, and building efficiency. Green Drinks will return, the CEO Crash Course, that's our accelerator progress report. There's rumor of another showcase with SMUD potentially, and we'll have an innovation trailer going out to connect the community with clean tech resources, funding, and make the community just a little bit better to live in. If you're interested in any of the past events, check out our past discussions. These two are specifically around the grid and microgrids, so they're right in line with storage. All right, so now tonight, what are we talking about? We are talking about storage. I am Thomas Hall, Executive Director of CleanStart, And storage is really important and it's really exciting. And here's some graphs that just kind of show you why. Annual storage market size from Wood Mackenzie and Power and Renewables, it's going to be exploding. The demand for the energy transition, the ability to get renewables, because anyone who's talked about how great solar is probably tired of people telling you it doesn't work at night. But it's a huge market. And one of the things that's contributing to it is the declining cost of storage. And there's even more potential for that to drive down even more. And I wanted to try to summarize why is storage important to the energy transition. And I wanted to kind of connect it to what storage of energy has always been. Gasoline is stored energy. And what storage enables us to do is storage coordinates. It enables coordination of supply and demand. New storage enables us to coordinate the supply of renewables with energy demand, which opens up all the exciting things of distributed energy resources, virtual power plants, microgrids being dope, and things that we don't even know of yet. So at this point, I would like to welcome our panelists, Mark Roest, program. I'm sorry, Mark, I've got your wrong title in there, but of Sustainable Energy. Michael Gravely, team lead and senior electrical engineer for the Energy Systems Research Office at the California Energy Commission. Garrett Woodroof, general manager of Villara Energy Systems. And first up, we're going to have Mark Roest, director of marketing and international development at Sustainable Energy, take us through his presentation. Mark has been a regular attendee at these meetups and has always pushed the battery discussion, talking about new chemistries and new possibilities in it. So I would like to welcome Mark Roest. I'm going to get his slides up in just a second.
And actually, so I'm going to go through the slides about halfway through. So hello, Sustainable Energy Inc. develops and will manufacture ceramic.
Let me get your slides up so everyone can see them. All right, everyone see the slides? All right, we're good. All right, go ahead. Sorry about that.
Okay. All right. So Sustainable Energy Inc. develops and will manufacture ceramic semiconductor materials science applications, including batteries, solar thin film, and substitutes for rare earth materials. We're developing a saline-based ceramic battery that we model reaching more than 2,300 watt-hours per kilogram capacity with fast charging capability, low cost, and high safety. For comparison, today's best batteries are around 350 watt-hours per kilogram, just 1/6 as much. We expect to reach 5,000 charging cycles in early volume production and past 10,000 cycles as we move up the learning curve. We're close to a testable prototype of the battery after making 14,000 electrodes over 9 years of development effort. We plan to fabricate the batteries in a ceramic floor tile factory, a mature, high-volume technology. Our CTO and founder, William Todorov, won the patent for the first multi-junction thin film solar PV designed for volume production in 1983. It was rated 22.5% efficient when the rest of the world was at 5 to 7%. After heavily modifying both the original silicon alloy fast semiconductor thin film design and a design for copper, indium, gallium selenide PV licensed from NREL in 1993, he stacked them for modeled 48% total efficiency. That is twice the best. I'm not ready to go through that, Tom.
Oh, sorry.
No.
All right.
Back to the beginning on that one. I'm doing a prelude to it.
All right.
Okay.
My apologies.
That is twice the best solar panel efficiency that is commercially produced today, so it only takes half as much space to meet the same demand, which is important for trucks. Imagine converting most of the existing vehicle fleet to full battery electric power with manufactured conversion kits, with thousands of cooperatives and traditional mechanics installing the kits all over the world. Now imagine putting up enough rooftop and canopy solar PV to power both buildings and all the vehicles associated with them, feeding batteries that provide load shifting from day to night and support local smart microgrids as well as main grids. This can become the way most people get and use electricity at home or work and on the road. Wind energy can make up the difference when solar PV and battery storage fall short in electricity deliveries. Wind turbines can also use on-site battery storage to smooth delivery through the transmission lines. Our CTO developed and patented a gearless wind turbine energy conversion generator, which would cost less than geared generators. It would be several times more reliable, so it would last far longer, saving the cost of multiple replacements. A 12 megawatt gearless wind turbine generator was modeled by NREL and will be manufactured by a European turbine manufacturer, or is already. It is a slight evolution of our design, which William had previously shown to NREL. Neodymium iron boron magnets make up a significant part of the cost of a large high-performance generator or motor. Several years ago, William was asked to design a substitute for the rare earth neodymium for a ceramics glaze that needed the special pink cast that it produces because it was out of stock at Alfred University, William's alma mater and the world's top ceramics school. He thought about it that evening, and the next afternoon he whipped one up and it worked in the glaze. So a year ago, he pulled out his notes and revised the formula for the neodymium substitute, making it part of a new formula to take the place of neodymium iron boron magnets. This formula may produce magnets with 15% greater pull force than the original neodymium magnets at a third the cost. William also designed a production process using the same ceramic floor tile fabrication technology we will use for the battery. We plan to use the substitute magnets in variations of the wind turbine generator design for everything from wheel motors for trucks and buses to ducted fans and turbofans for aircraft to power for ship propellers. All of them will use our batteries. Many of them will also convert sunlight to electricity with our solar thin filaments stored in the batteries. Now I'm going to show some slides that focus on the batteries and our first market, which is trucks that work in ports and rail hubs. So I am the Director of Marketing and International Development at Sustainable Energy, Inc., and I work with a team that includes Cyber Switching, Green Fleets Group, and the Silicon Valley Clean Cities Coalition. Next slide, please. Sustainable Energy, Inc. is developing a family of advanced and disruptive fired multicrystalline ceramic semiconductor technologies, battery and solar PV for distributed energy, supports the solar fueling concept, extremely compact and deployable, and highly disruptive, performance to cost ratios. Next slide, please. A safe SEI ceramic battery will have 3 to 7 times the range per kilo of lithium batteries. That means heavy trucks may go 750 miles on one charge with a full payload while observing the gross vehicle weight rating limit. Twice commercial solar PV efficiency, half the area to provide the energy they need. Next slide, please. The founder, CTO, and board chair is William Todoroff, who set the stage for solar PV in 1983 with his multi-junction thin film patent. Now he's redesigned it and he's building a fired ceramic battery to solve range, safety, and cost issues. And I'm building the business as a whole systems thinker with 45 years multidisciplinary experience. Next slide, please. So from research to production, we start with handmade R&D, and that will scale to a 50 million square foot per year ceramic mini-tile factory, repurposed to make our mini-tiles. Next slide, please. We'll sell to OEMs, but the focus is battery electric vehicle conversions. We have a customer number 1 who wants to convert 6 trucks and provide parking and solar charging for 300 trucks at a planned trucking services center and 300 more in another area in a port, the Port of Oakland. A diesel to BEV conversion kit maker will buy from us when we launch. He tests batteries on his NASA-grade test system that he made himself. We plan to convert 8,000 Class 8 trucks to BEV for the California Air Resources ban on diesels with engine model year 2009 and earlier in ports and rail hubs during 2022. The ban starts January 1st of 23. Then scale with both trucks and buses. Next slide, please. So we're going to swap SEI batteries and Ed Monfort's motors in and diesel engines out for long range and full payloads. The I can't deal with, okay. Utilities are aiming to make I-5 a West Coast electric highway for commercial trucks. Next, and we have a a person on our network who has sites all up along I-5. Now, this map shows you the percent of residential customers with solar storage cheaper than the utility retail rate. And that would likely also apply to where the best sites are for truck purchases of solar energy instead of from the grid. So California is 90%, Arizona 85, New Mexico 84, Texas 60. The Appalachians and the Northwest are not good places for it, but you can see most of the rest of the country is pretty good. Next slide, please. How to understand the economics. The cost of batteries and solar PV is a drop in the bucket compared to global GDP and to climate chaos costs. Cost is saved during financing for no net negative cash flow. And I just lost my slide, Michael, okay. And paid off in 2 to 6 years, depending on the application. If customers own a battery electric vehicle, photovoltaics, and storage and management, and can realize their full value, they can increase disposable income by 25 to 30% after paying off the financing and achieve prosperity. The reason is that throughout most economic classes, people spend 15% of their income on transportation and 10% for electricity in the United States. And outside the United States, it's 15% for electricity. That's where the 25 to 30% comes from. Next slide, please. Onward, converting and charging trucks, buses, and aircraft. That's where we're headed. And we have done a bunch of designs of aircraft. Next slide, please. Thank you very much.
All right, thank you very much for that presentation there. And so we're going to do a couple quick swaps here, so I'm getting ready for things. So next, I would like to welcome Michael Gravely to present. He is the team lead and senior electrical engineer for the Energy Systems and Research Office at the California Energy Commission. His team is managing over 300 million in microgrid energy storage and related energy research and demonstration projects. In this role, he oversees the full spectrum of research activities to improve the California electrical grid, including assessing future energy storage needs in California and addressing the grid-related issues associated with integrating higher concentrations of renewables. In 2020, the Energy Commission awarded over 100 million in state funds, a vendor cost share investment, to over 25 new grants to complete research and demonstration projects with new and emerging energy storage techniques. One key area of this research is focused on understanding the capability and value of long duration energy storage solutions. That's from 10 to 100 plus hours in time. To assist California in this transition to reach the goal of 100% zero carbon resources by December 31st, 2045. That was the goal of that investment. Gravelli has a BSE from Virginia Military Institute, as well as an MSE from California State University, Sacramento. Great to have you back. I'm assuming that was at the College of Engineering Computer Science, where I'm going to assume you went there with Paul Lau of SMUD. Prior to the Energy Commission, Mike served in executive positions in the federal government and private industry, including addressing the business challenges of a startup energy storage company. Mike also serves as a military advisor to the chair of the California Energy Commission. As military advisor, he leverages his over 22 years of military service to coordinate Energy Commission activities with the Department of Defense bases in California. So with that wealth of experience, I would like to welcome Mike Graverly. I'm going to spotlight you and you'll see your slides come up. And when you do that, you can go ahead and start.
I think you can hear me okay. Okay. Yeah, for this one, I want to talk a little bit about the Energy Commission role in the advancement of energy storage. The Energy Commission is the lead agency in the state for the implementation of SB 100, which is our legislation requirement to have all clean energy by 2045. Next chart. So when you do this, and I'll talk about other states, it's very important to understand as you get higher and higher concentrations of renewables, energy storage becomes more and more important. And actually, the higher the percentage of renewables, longer duration energy storage, according to the models, becomes even more important than short duration storage. Next chart. So last year or this year, the key agencies within the state, the Energy Commission, the Public Utilities Commission, the Air Resources Board, and the Independent System Operator got together and produced a joint report on how do we get to our goals of 2045. Two key elements that are defined in that report is there's a need to triple the growth of renewables to meet that and the build out to meet that requirement, and 8 times the requirement to an energy storage. So California is going to be the energy storage market, probably in the world for the next 5 to 10 years. And you'll see more as I go forward. Next chart. So California, I was actually selected 20 years ago when I entered the Energy Commission for my energy storage background. And over the last decade, we have done a wealth of projects, everything from residential to customer side to grid scale, and the full spectrum of technologies from large scale like compressed air and pumped hydro to utility scale, flow batteries, flywheels, advanced batteries, zinc batteries, and we have quite a few projects that are using lead acid lithium ion batteries. Next chart. Well, this just shows you the technologies we're investing in now. We probably have 15 to 20 different technologies right now, depending on whether you're talking in the small grant area. So we actually award grants in 3 areas. One is applied research, one is demonstration, and one is in market facilitation. So for applied research is basically when you're building your first prototype, and technology demonstration is you have an operating system and you want to grow it, or you grow closer to commercialization. And in technology demonstration, we focus on barriers and permitting and things to make systems work better. For example, we're funding a energy storage guidebook to help California cities site up to a 1 megawatt size storage in their facility and help them with the permitting process. So the technologies we talk about are obviously advanced batteries. For example, we have 6 different companies that are using zinc-based batteries right now. We have about 4 companies on flow batteries, 2 for flywheels, the thermal storage, a couple advanced pumped hydro. We have 1 primary project right now. We don't do much when it comes to just pure pumped hydro because that's pretty much a commercial project. And we have done work in the past on compressed air. We are doing a lot of work on green hydrogen, and I'll talk later. We're expecting to get a bunch more money to address green hydrogen. And obviously, one of the goals of green hydrogen is seasonal storage in the future. Next chart. So as I mentioned before, in 2020, there was a big bill. $100 million in 1 year was a big investment for us for energy storage. That includes about 65 million state funds and about 45 million in contractor match funds or grantee match funds. We did some lithium ion batteries where we looked at battery second use, but the majority of the funding was for non-lithium ion. We awarded a full spectrum. So we awarded 8 grants to do 10 hours of storage, and we did another 3 grants to do 100 hours of storage. And the 3 grants, the 100-hour storage systems are in the early development phase, so they will be building their first prototype in California, probably in about 18 months. They should be through building those. And then we also awarded 2 $1.5 million grants, one to the university and one to, just a second, my light goes off in this office here. After you sit still too long. So to look at one to university and one to industry, E3 and University of California, Merced are the 2 grantees. And looking at long duration storage, And as California goes to the future, how should we mix up that? Right now, the current model shows 90% of the storage should be short duration, which is 4 hours or less, and 10% it should be long duration. I expect that number to grow as we get down the road and learn more about it. Next chart. So this is a big area for us. So I didn't show the chart here, but the Public Utilities Commission has what they call the Integrated Resource Plan. And they show that we need 10,000 megawatts of storage, of which 2,500 has been funded so far, of which only 1,500 has been actually installed and operating. So if you look at the next 6 to 7 years, we'll be basically buying another 7,500 megawatts of storage. And that plan I talked about that we did with the multi-agency says we need another 20 to 30,000 megawatts of storage after 2030 to reach our goal by 2045. So you're talking about a huge change and huge opportunity for energy storage. One of the big questions for us is the different durations and even defining what is long duration. For California, we're defining long duration as starting at 8 to 10 hours, as I mentioned, the grants that we do. And then seasonal is typically a week or more, but we're starting to look at those. One of the things I'm trying to figure out is what is the duty cycle? So I mentioned we have 4 different grants that are doing 100 hours of storage. And so the question is, if you have 100 hours of storage, how do you use it? And then when it comes to seasonal, there was a legislative workshop recently on seasonal storage that is looking at that. And so one of those questions becomes, if we're going to have kind of an energy reserve like we do with a national fuel reserve, a state energy reserve in the future. But we're trying to struggle. If you've got a technology that you're going to use once every 2 or 3 years, and it costs you $50 million, how do you finance that and how do you maintain that? Next chart. So the last thing I want to mention is that this is a very exciting time. Last year, the governor signed a budget of which it included in the budget $735 million that would come to our division to do 4 things. One of those was long duration storage, $340 million to do long duration storage demonstrations, $100 million to work on green hydrogen, and then another 210 for industrial decarb and food processing. So the 340 million, and what happened was originally the legislature the money is in the bank. The legislature is supposed to release it. They were going to do that by October, but they decided to defer that decision until January. All indications are eventually they will approve this and we will get the money to do that. And in this one, we'll be looking at projects that are in the range of initially 1 to 5 megawatts for 8 to 10 hours, and then later 5 to 10 megawatts. One of the big challenges in these projects is to get financing. When you look at all the projects we have in California, most of them are power purchase agreements. If you have lithium ion, there's no problem getting a banker to finance you. If you have a new battery, if you have a flywheel, if you have a flow battery, it's almost impossible to get a bank to finance you for 20 years. So we're working a lot in trying to do that. And this money will help us a lot in advancing companies to do that. Next chart. And so I'll be happy to answer questions later about anything and all the technologies we're working. So I have been to do that. And at the end of the presentations, we'll have an open discussion. Okay, thank you.
All right, thank you very much, Michael. Next, I would like to welcome Garrett Woodroof, General Manager of Villara Energy Systems. You might recognize Villara from some of the other companies that are kind of under their umbrella, which includes HVAC and other energy efficiency programs. They've actually done quite a bit of growth in this area, and it's been exciting to watch. So I'm really interested to hear what Garrett's going to be sharing today. So I'm going to spotlight you, Garrett, and go ahead and share your screen when you're ready.
Wonderful. Thank you, sir. Let's see here. My screen sharing option seems to have moved. Oh, there it is. Share. So we'll stop somebody else's screen sharing. Yes. Wonderful. Okay, is that working okay?
Good to me.
Wonderful. Okay, I'm going to stop my video for bandwidth reasons. Okay, first off, I do want to thank all of you for tuning in. Also, many thanks to CleanStart for putting this together, for inviting me to speak on this exciting topic. Today, we're going to talk about home batteries and battery chemistries. So why should we care about home batteries? Why are they even interested in purchasing a home battery? Two pretty compelling reasons. One, that's you're probably no stranger to, is peak shaving. So most utilities, at least in California, especially in California, are moving their consumers to time of use plans where they pay more for energy during peak hours and less for energy during the off-peak hours. Sometimes that difference is maybe only 10%, sometimes 17%, sometimes 18 cents more per kilowatt hour. And so when you can install a home battery, then you can charge that battery while the energy is inexpensive to purchase, and then just rely on the energy in your battery and avoid those peak rates. So that peak shaving is compelling. Probably even more compelling is the backup application and value. So I know I live in an area where we had some extended blackouts a couple of years ago. The expectation for most of the customers that had solar arrays on their roof was that the solar would power their home during the day while the sun was shining. And then, of course, the reality was that most solar systems don't work if the grid is down. And so they were not generating electricity, and they were unable to power the home. So the reality, they were just as powerless as the others, but probably quite a bit more frustrated. Many of those have since installed batteries. A small battery, and for the axes here, you can see different months of the year and then different times of the day. So a small battery can not only allow your solar array to produce during the day, but it can also give you energy even into the evening hours. A larger battery can do that and oftentimes give you energy all the way through the following morning until your solar system is able to start producing again. So pretty compelling case for backup for even just a small battery, let alone a large battery. So people are interested. So those are home batteries. I want to talk to you a little bit about lithium-ion batteries, because not all lithium-ion batteries are created equally. So real quick, a lithium-ion battery is simply called a lithium-ion battery because they use lithium ions and they move those between an anode and a cathode to induce electrons to go between the anode and the cathode. But there are many different options for materials for the anode and the cathode. So here are 4 different flavors of lithium-ion batteries. An older one that you don't typically see in home batteries anymore is the nickel cobalt aluminum oxide battery. A newer one is a nickel manganese cobalt battery. An even newer one that's becoming more and more popular is a lithium iron phosphate lithium-ion battery. Notice that each of these batteries uses graphite in the anode. They are only differentiated in the cathode. So Villara Energy Systems and I am most excited right now about lithium titanate batteries. The lithium titanate batteries and battery chemistry uses a fundamentally, elementally different anode material, and that gives a few different advantages. So the first is power. Lithium titanate can release and receive more ions, more electrons faster. So that means you can charge and discharge the battery faster. Most batteries can't charge very quickly, or else they're prone to wear out or even overheat. The second reason we like lithium titanate is safety. Graphite is flammable. It's essentially pure carbon. And it is a 2 out of 4 on the NFPA flammability scale. And contrast that with lithium titanate, which is non-flammable and a 0 out of 4. Third reason is useful life. Lithium titanate just lasts longer. It doesn't grow dendrites and wear out as quickly as a graphite anode does. Another reason is that lithium titanate is more tolerant of extreme temperatures. So a lot of batteries will claim that they're operating through, let's say lithium ion batteries will claim operating temperatures of down to -4 degrees Fahrenheit and up to around 122 degrees Fahrenheit. Dirty little secret of the battery industry is that most of the NMC and LFP batteries cannot actually receive a charge below roughly freezing temperatures unless they employ active heating element like an electric blanket for your battery, preheat it so that it can charge it up. The reason for that is that graphite, when it gets below freezing, you run the risk of lithium plating if you try to charge the battery. So many of them won't charge below roughly freezing temperatures, but can still discharge down to about -4 degrees Fahrenheit. Contrast that with lithium titanate, which can go all the way down to -22 degrees Fahrenheit, all the way up to 131. Okay, how'd that picture get in there? All right, so now we've talked about home batteries, we've talked about lithium ion batteries. So let's put those together and talk about the value of home batteries. And one of the things that Villara Energy doing is really trying to educate the market and to think about home batteries differently. So another dirty little secret of home batteries is usable energy. So when a home battery is installed, the installer will set a lower limit and an upper limit on the state of charge. Essentially, batteries wear out too quickly if you let the battery state of charge get too low or too high. So LFP batteries, for example, typically installed with a lower limit of about 15% and an upper limit of 85 to 90%. But 15% to 90% means that only 75% of the battery is actually usable on a daily basis. Contrast that with an LTO battery, which you can take all the way down to about 4% and all the way up to about 99%. So a whole lot more usable energy on a daily basis. So more usable energy, 20 years instead of 10. And by the way, you can even get multiple cycles per day. This all kind of comes together to mean that an LTO battery can deliver 2 to 4 times the lifetime energy. Think of lifetime energy like the total miles you've put on your car, like the odometer. I think lifetime energy is a very important and overlooked metric when it comes to valuing batteries. So when you are comparing home batteries, I really want you to consider these 2 value metrics. Most of the market right now thinks in terms of one-time use. How big, what is the battery capacity and how much does it cost? I think that a better way to think of the value of batteries is to think about lifetime energy per cost. And of course, with lithium titanate typically costs more, but you can get so much more lifetime energy that the lifetime energy per cost metric is pretty good. And with the additional power of lithium titanate, you get also a pretty good value in terms of power per dollar. So that is everything for my presentation. I'm looking forward to the discussion here coming up in a bit.
All right. Well, round of applause for all 3 of our presenters because those were really excellent presentations.
Oh, you're here, Gary. I didn't even notice you come in. Oh, you're on your phone?
I'm on the phone.
All right. Well, I'm going to quickly switch over and we can start the. So now we're on to the presentation portion. So I'm going to welcome back Mark Roest, Mike Garrett, and Garrett Woodroof. I'm going to let Gary go ahead and start it. I'm going to spotlight the 4 of you. And
all right,
take it away.
All right. Well, just following on with you, Garrett. Interesting that you chose the lithium titanate batteries. In terms of suppliers of the LTO batteries, for a number of years, the only serious vendor was Toshiba. But I don't know what's happened in the last few years. Are there now multiple vendors for the LTO battery?
I think Toshiba is still the best source. And by the way, Toshiba is exactly where we source our lithium titanate battery cells.
All right. And I mean, the way they construct those, you could either try maximum power or maximum energy out of them. So I don't know where you've come up on configuration, but there was a lot of flexibility in what Toshiba was offering. Is that what you found too?
Yeah, they have kind of 2 different lines. One where they're really optimizing for power, as you alluded to, and one where they're optimizing for energy. However, However, the battery line where they're optimizing for energy, with the combination of battery cells and series and parallel that we're using, gives you all of that energy, but also a whole lot more power compared to everything else.
Right.
So that ended up being the most compelling combination for us.
So say that again. The one that you took was the power option, or did you do a mix of batteries in your system?
So we're using the more energy oriented Toshiba batteries.
Okay.
But in spite of the fact that we're using those, we're delivering about twice as much power as most of the other batteries on the market.
Yes, yes. So, I mean, looking ahead, Garrett, you've got GM sort of made its bet on a series of batteries. Ford and BMW, I think, have made a bet on another kind of battery. Tesla's made its bet with QuantumScape. Those are all batteries that are probably more oriented towards power. And of course, in electric vehicles. But you seem to have a pretty good understanding of the landscape of batteries. Do you see the energy storage capacity of batteries going up dramatically in the next few years, or are we at some kind of peak in volumetric energy density?
Well, I mean, it's funny that you mentioned the electric vehicles along the way there, because a lot of the ways that we think about batteries really come from the electric vehicle market, where people are appropriately and hyper focused on things like energy density, like per mass, because for an electric vehicle that weighs twice as much, that matters a whole lot.
Right.
Versus, and even volumetrically, that matters. That makes a pretty big difference. People have quite a bit more room in their garage than they do in their trunk. And if you're mounting something on a wall, I kind of don't care if it weighs 250 pounds or 400 pounds, as long as it stays out of the way and doesn't fall off.
Well, that's probably a good idea. Yeah, it doesn't fall on your head when you're walking out in the garage. How about pricing wise? Can you tell us anything about where you are, like relative to Tesla Powerwall?
Yeah, so let's see. Our battery you might have seen along the way is called the Villara battery. So we have a multiple sizes of batteries. So of course the price depends on the size and things like that. What people are really going to care about is the all-in cost of the project, because you're going to care about the inverter. You're going to care about transfer switches and cabling and everything else in terms of that. The Villara battery and a system with the Villara battery at its core is going to cost more than most of the other alternatives. But in exchange for that, you get a battery that lasts 20 years instead of 10. So you got double the useful life and roughly double the power. And I don't know how to measure fire safety, but better safety, in my opinion.
So when you talk about putting a system into a home, are you talking about 10 kilowatt hours capacity, 15 kilowatt hour capacity? What's your thought in terms of where you see the sweet spot?
Yeah, so we have two primary sizes. One is 5.75 kilowatt hours. The other is 11.5 kilowatt hours. How long those are going to last, the answer to all those kinds of questions is always it depends on the home and the time of the year and, your particular usage and the day and even your mood. But we picked those sizes because for a lot of homes, we think that 5.75 kilowatt hours will probably get them roughly through peak hours. So if they're focused on peak shaving, then we have a smaller battery that can serve that need pretty well for a lot of folks. And 11.5 kilowatt hours for a somewhat efficient home can actually get them all the way through the night if they're careful about their consumption and if they're in if there's an extended power outage. So that's the reason for those two sizes is, hopefully a 4 or 5 hour peak rate period, and then getting somebody through the night so that their solar is producing the next day.
All right. Well, that's very interesting. Do you have any intelligence built into the battery system, like a communication capability with the utility to use it as a dispatchable resource, ultimately part of the microgrid type systems?
Yeah, I didn't want to cover too much of the product because I didn't want it to be. I want to be more technology focused, not too salesy on this. But yes, there is monitoring available. California Rule 21 compliant, CEC approved, 1741 SA. So it's even the systems that are already installed, I believe, could be configured to become a distributed resource for a forward-thinking utility.
All right. Well, sounds like you've got a lot of opportunities there that in the way that you're going to develop that battery system and where it might evolve into the future. So let me turn back to Mark. Different set of questions. Give me a sense, Mark. I mean, very good presentation there. But where are you in manufacturing capacity now? We saw the thing on trying to do the investment in a manufacturing facility on your slides. Are you manufacturing any substantial quantities of those now? I heard the metric on several thousand something was being produced, but in terms of full batteries, can you give us an idea where you are on that?
Yeah, we've been operating in a garage like Hewlett and Packard, and for the last 6 years or so, in the Valley of Death, doing batteries by hand and firing them in a ceramic kiln that's got about a cubic foot of space inside it, and no instrumentation other than cones. So we are not in production yet. We are working on our testable prototype, and once we get that done, so we've been going, it's said that batteries are harder than solar, and they are. If you're trying to make an end run around the entire industry instead of incrementally improve what's already being done, it is a long, hard road. But we think we're near the end of that road. And so we're figuring that if we can get to a point where we can order a factory by March, April, or May, and then there's a good shot at having one installed and commissioned in September. And that would give us October, November, and December to handle the long haul trucks and the trucks in the ports and rail hubs of California, which currently have 2009 and earlier engine model year diesels, which are all going to be banned as of January 1st, 2023. So we're partnering with the conversion kit person I talked about. He's in production. He's going into production and is going to get a factory for his conversion kits, and he'll be using the lithium batteries that he's chosen at first, and then but for 3/4 of the trucks that are, I think 3/4 of the trucks that are affected by that ban, can work with lithium batteries without having a range problem. For those that do have a range problem, because the weight of the batteries and the gross vehicle weight rating issue, those batteries, we would come in and provide him the batteries for those. So he's our first customer, and the guy in the port that I mentioned is our first specific end-use customer.
So where are you in terms, I mean, very good that you've got the interest of the end-use customers. Where are you in interest from any ceramic manufacturers in terms of helping out to make this?
We expect to, well, so William Todoroff was a consultant to the ceramics industry. He got his master's degree in ceramic manufacturing fabrication and has been doing this for 60 years. So he is going to buy a factory and run it. And once it's perfected, that'll be a pilot plant. 20 to 30 million kilowatt hours per year is what we consider a pilot plant. And he would run that. And then hopefully by 2023, we would have 150 million kilowatt hour per year full-size test, manufacturing plant. And those are ceramic floor tile factories with an assembly plant tacked on at the end. And so, let's see, your question. I'm sorry, I
Well,
missed.
I mean, making a ceramic for a battery is more complicated than making a floor tile. And so in terms of expertise and experience, just wondering.
Yeah,
we-
so
with-
William has
with-
that, yeah.
with-
William is the master of that.
Okay.
And he is the one who was brought into ceramic tile factories to solve problems that the families that owned them couldn't solve.
Well,
So
that's
we
pretty
already
good
have that. But what I'm saying is that we will, okay, what I forgot that I was trying to remember was that after we are in production and making factories, we will be able to convert existing ceramic factories at probably 100 million kilowatt hours per year rather than 150. So we do have a plan for being able to convert existing factories, and there's thousands of them around the world now.
So what you're going to need a certain amount of money, and I don't know whether you mentioned it, in order to get these factories going, but what's the raise to get the kind of factory for the pilot fabrication that you're talking about?
That was 100 to 300 million dollars.
Well, that's a lot.
Yeah. So we figured we'll start with a laboratory. In the laboratory, we'll be doing some small stuff to prove that it works in different application areas. And if it works as spectacularly as we expect, then we expect that the money will be forthcoming.
All right. Well, I mean, it turns out you're in a good time because VC money is going for bargain prices right now. And so you're potentially riding the crest of a very useful wave.
Yeah. Now, the other thing is about that funding is that the pilot plant could fund a full production plant in a year of full operation. And a full production plant could fund more than one full production plant per year of operation. So we have the potential for exponential growth with internal funding. It's just the start, it's the launch, the catalyst that needs to go. But what that's going to do for the investment and return on investment is pretty spectacular.
Yeah. Well, it's a very creative and interesting idea. Now, let me take advantage of all the expertise that you have in this area, because Mike Gravely has been focusing, as we ask him to, on the long duration storage, which is, I guess, different than what you're talking about for trucks and different what Garrett was talking about for the home. But in terms of your technology, would you foresee an application where you could meet the kind of metrics that that Mike was talking about for long duration storage? Or is there enough energy density?
Absolutely, both directly, because our actual cost, we expect our cost to go down below $20 a kilowatt hour in terms of the marginal cost of goods sold within a few years. And we also plan to build these factories the geometric progression leads to the ability to stop fossil fuels by 2030 and keep going, keep manufacturing batteries for the resilience needs, for emergency use, and for direct air capture to complement the massive amount of natural capture of carbon that we need to do. We can do, I figure we might do 50% of the amount of batteries extra just to do air capture, and all of that would be available for resilience whenever it comes up. So all of that would be doubling as long-term storage. But if I can get down to $20 a kilowatt hour, and I've got a lifetime of 10,000 hours, you know, the long duration storage is there, especially if I'm making extra batteries, because I've basically used up the direct addressable market, and now I'm ready to keep on, but I've still got those factories that want to keep producing a bit. I do plan to shut down some of the factories, but not until we've got all the batteries out there that we really need, and then keep some of them open for replacements.
So volumetrically, just as the size of what you're talking about there, I mean, you said you saved weight, you do have a higher energy density. I would expect then that compared on the stationary side to a lot of what's being done with lithium-ion batteries now, for the equivalent performance, your facility would be much smaller. Is that
It
correct?
would be smaller, and I'm well, if we're at the 1 or 2 kilowatt hours per kilogram, we're probably also at 1 or 2 kilowatt hours per liter.
Mm-hmm.
And so that's sort of close. I don't know, we'll find out how exactly close it is when we know exactly what actually works in the battery.
Mm-hmm. Well, it's a very exciting prospect. There was a question I saw that came up on the application for the marine market, and I don't know whether that was for ships coming into port or something else.
Okay,
But
well, that would start with, we would start with shoreside power, but I'm actually talking about powering the ship. Now, in 1975, I designed a mast and spars for a Dynaship sailing cargo ship, which would be 180 foot tall mast, 185 foot mast with 90 foot spars. And it came out at 15,000 pounds instead of 200,000 pounds because I made a fundamental design decision. The idea there was that you have sails, and when there's enough wind to push the ship to the hull speed, you engage the propeller as a generator and you store that electricity in batteries. And I didn't even know I was going to have batteries back then, and I didn't know back then about the whole idea. But the technology exists and will be furthered for doing that. And we also can use the wind turbine generator that I mentioned can be used as a large engine motor generator for a ship.
Mm-hmm.
You can have a series of them if you need it. So yeah, it can be done. We certainly can make ships that can not ever need to buy fuel.
Very interesting. Well, you've already done a lot of work on that, it sounds like.
Yeah, I've been interested in that since 70. I worked on the ship thing was in October 75.
Yeah.
Well, Gary, we do have a hand up from Dan.
Yeah, I was just going to go to that. So what's the question there, Thomas?
Daniel, you have your hand up?
Yeah. A couple of questions, Mark. What's the thickness of your ceramic? I imagine you're making really thin ceramic electrolyte types of the sheets. You said it's a saline, so is it a salt-based type of ceramic?
No, we're actually making about 2 millimeter thick anode, cathode, and we're aiming right now at a solid state electrode, which would also be a couple millimeters. So we're looking at about 6 millimeter thick by about 5 by 7 centimeters in sheet size.
Interesting. So you're seeing good results with that, because I know some of the other solid state companies, they're making really thin layers to increase the energy density via 3D printing, like binder jetting and other stuff.
Our strategy is to make crystals in the kiln, profusion of multiple different crystals in the kiln, which are semiconductors. And we'll find out soon, really soon, what kind of result we get in terms of charging, holding a charge and that. But the volt open circuit is around 2 to 2.3, and there's something we're working on that might be 2.9, and the amps are up there. The amps are it's designed for 50 amps around, plus or minus.
It'd be interesting too to see what kind of results you can get, because the solid state, I know it's been notorious for like a lack of ionic conductivity in the ceramic material, and that's kind of you keep hearing 2030, like the big players right now, Saku and Factorial. You probably heard about them, Ford and BMW. They have something, so it'll be kind of interesting to see how this plays out, and look forward to hearing more about your stuff in the future.
Thank you. We are trying to make an end run.
I've got a question for Michael. You've heard kind of, Mark Roest, who's trying to develop a battery and manufacture it here. Villara, you guys are getting your batteries from, I think it's Toshiba. So when the CEC is looking at, investing in a lot of this new battery technology that's going to scale, how much does it consider, I guess, the supply chains for it and where it's kind of getting developed? How does it kind of weight that? Is it strictly on cost? Or
So, yeah, so let me, we mentioned long duration storage, but I have to go back and explain we have the full spectrum of programs. So we have a small grant program that's 150,000. If you get that, you can get another $400,000. We have programs to pay.
I'll see it, everyone.
To pay people to build their manufacturing in California. We have other grants that we work where they give follow-on grants to help in the Valley of Death, KP. A lot of the time I've been spending lately has been on the larger system. So one of the challenges has been meeting the needs. And so you mentioned supply chain. So one of the challenges we're facing right now in stationary batteries is the lithium ion supply chain is pretty well getting clogged up. We have, as I mentioned earlier, 2,500 megawatts of storage has been approved by the Public Utilities Commission. 1,500 has been installed. 1,000 is supposed to be installed in the next year. Another 7,500 will be procured in the next 2 to 4 years. However, what we're learning is you can ask for it, but you ain't going to get it. It ain't out there. And so if you want lithium ion, we're talking 10, 20, 30, 50 megawatts. We're not talking about a couple hundred kilowatts. And so I got a call last summer. They said, okay, in your non-lithium ion batteries, if we gave you the money, how much could you feel? This was July. How much could you feel by the summer of 22? And I said, seriously? I said, yeah. I said, 5 or 10 megawatts, maybe 20 megawatts for 4 hours or 8 hours. And actually, so I actually talked to 30 companies and asked them if we had the money, what could you deliver by the summer of 22 to be commissioned by June so it's available for the summer? 2 companies out of 30 said they could do it. One was 3 megawatts for 8 hours. The other one was 4 megawatts for 10 hours. In fact, that money I mentioned, the 340 million, we were supposed to get that money by October, and we had made arrangements to sign those agreements by November so they could install. We didn't get that point, but the point was supply chain. They were looking for batteries that had different supply chain than lithium ion, and that's going to be a long-term issue. Right now, if you talk about the growth that California needs, it's just lithium ion. We're not the only ones buying it now. It's growing around the world, and they're making commitments around the world. And the 2 companies that I talked to, in fact, had just received $100+ million each of them, and they put a lot of that money in their manufacturing capacity so they could actually generate things in less than a year. So, and when we look at things going forward, batteries that use non-rare earth materials, batteries that use readily available materials are scoring much better in doing that. So, we just this month submitted our next 4-year plan to the PUC. I didn't mention it, but we get about $150 million a year. And last year, we just got a 10-year extension to our program, and we were doing our first 5-year plan. The first year had already been done. And so we do have a lot of funding in there for energy storage. We spend a lot of money on demonstrations, so we're kind of going back in the cycle now, and we're going to be investing in companies like you're talking about here, companies with new technologies, and giving them a chance, typically a $1 to $3 to $5 million order to get things. So I think for those of you that are in the startup business, there is going to be some real opportunity to commission starting in about a year for the next 2 or 3 years for people to get that demonstration project out in the field, their first demonstration project, where what we focused a lot on when I talked about the 2020 was people who already had an operating system, and now we ask them to double the duration and anywhere from 15 kilowatts to 400 kilowatts for 10 hours was what we were looking for on those 11 grants that we talked about for long duration. In California right now, there's some questions about, what is the proper mix of long duration and short duration? Short duration is classically defined as 4 hours or less. And what I mentioned in our case, if we get the legislation that we've asked for approved, then in fact, what will happen is California will define long duration storage as 8 hours or more in legislation. So I guess we'll have a definition of what is long duration storage in California, at least. When I talked to NYSERDA, actually, a year or so ago, NYSERDA had a goal for batteries of 1,500 hours, and they doubled it to 3,000 hours. And I asked them, when they doubled it, how much long duration storage did you consider? And they said, we didn't consider anything over 6 hours. So they weren't even looking at long duration storage. Well, now they are. They're beginning to realize it's out there. So I think from those of you that are interested in, you have my number. I'm happy to talk to anybody that's here tonight that is interested in what opportunities the Energy Commission has. We have small grant programs that run year round. We probably award 80 to 100 grants a year in this area. About a third of that 150 million that we get goes to batteries. The other 2/3 goes to renewables and transportation and energy efficiency in other areas. So there is a huge opportunity. I think, the growth market, I've been talking all over the world in the last 6 months about long duration storage. It's a very hot topic right now. And the opportunity is going to just continue to grow. But I think, that there's one of the questions we get into is if you're going to do 8 hours of storage versus 4 hours of storage, the duty cycle is pretty common. You're going to do it every day. It'll operate. You need 5 or 6 hours to get through these peak demand periods, but it's going to operate every day. If you have 100 hours of storage, that's a different question. How do you operate it? How often do you operate? Some of these technologies are, you mentioned $20 a kilowatt hour. So those are the range that we're talking about, down to 10. Some say they can get to 1. I'm not sure they'll ever get there. But the point is, they have very inexpensive materials, but the battery duty cycle is also limited. They can't cycle it every day. They have to cycle it on a high demand. So what we're doing now, a lot of the effort I'm doing now is trying to understand the duty cycle we would need if we were to award 100-hour storage in the next 2 years. So, I can tell you, if we go to 2040 and we've installed 30,000 megawatts of storage, it's easy for me to say, oh, okay, now what do I need in seasonal storage? Because I know what's not working. When I've got 1,500 hours of storage installed, and I'm going to install 30,000 hours, I find it hard to me to believe when we are short of batteries, if I install a 100-hour system and say, oh, you can only touch that twice a year, that ain't going to fly, So we have to have a technology that can meet the needs of the grid. And so we are looking, because some technologies can actually work every day and still generate 100 hours. Some technologies can't. And so I'm really trying to decide that, because we are looking at awarding 100-hour, just say 5 megawatt, 100-hour storage system within a year or two. I'm expecting to take another 2 years to build it. So, 3 to 4 years would have a system out there. So we're still talking in an environment where the state doesn't have enough batteries to meet their needs. So that's going to have to respond when needed. Yeah, go ahead.
Yeah. First of all, back to your supply chain issue. So other than the electrodes and the conductors, the rest of the battery is generic ceramic materials ground up into powder as they come out of the ground. No refining, no sending it to China, any of that. And the kind of discharging profile that I'm hearing is discharge 90% or 85% and charge up to 100% daily or multiple times per day. And because we're also looking at fast charging. So he actually said, he might be able, one model looked like 4 minutes to do from 20% up to 80% in a 160 kilowatt hour module.
Looking forward to that.
so-
I'm gonna call on Peter Mackin because he's had his hand up.
Yeah. So I think I'd certainly like to compete for that. But the other piece is if we could bid on both X number of batteries that are 2 hours or 4 hours and Y number of batteries that are 8 hours, then as one package, we could make that work pretty well, probably.
Go ahead, Peter.
So actually, I
yeah.
was going to say one thing real quick, Gary. One of the questions that are in the chat, I was just looking to see if I could answer any. But one interesting question was how many battery companies haven't made it in the last few years. So I mentioned that one of our high priorities that we're working with the investment communities. I've had many discussions. I'm working with them to develop what we call a bankability matrix that we would give to our grant recipients and say, this is the goals you need to strive for. If you can meet these points, then we think the investment community will come to you, not venture capital, but project financing. Not there's a lot of people that will invest in the company, but they're not going to pay for your demonstration. You need project financing to get there. And so the truth is, right now I'm working I've been here 20 years. I've probably had a dozen bankruptcies. I got 2 right now that I'm doing. One of them is a simple one that they don't have a project and we're just mutually agreeing not to go forward because they're insolvent. The other one has 5 grants that are batteries all over the world, all over the country. Actually all over the state. So we have 5 different applications and all these batteries are sitting there and the company is no longer around. So we have to work out the details of what do we do with those? We have to remove them. Nobody wants something they can't get support for. So, and that impacts the investors see that. So, one of the challenges you run into, if I'm going to finance you for 10, 20 years, how do I know you're going to be around or someone's going to be around to support me for 10, 20 years? And we are getting, more support, but one of those companies that we're talking about has been around more than 10 years and, it's not around anymore. So that's a reality. And obviously one of the things we do is try to help companies help to grow their manufacturing capacity, help to grow their engineering force and things so they can have a better sense. So our ultimate charter, when you look at the money we get from the state every year, actually it comes from the ratepayers. Our primary money we get comes from the ratepayers. The 340 million comes from the general fund. But the ratepayers, and we have to give value back to the ratepayers in doing that. So, we are trying to commercialize products. So our goal is to have new technologies, innovation that's 5 or 10 years in the future that doesn't exist today. And I can tell you categorically, when you look at batteries, and Mark brought it up, look at the cost today. And I'm not sure, I saw your chart. I hear these stories of buying batteries for $100 a kilowatt, different things. We haven't been able to do that. I've got 50 grants out there buying batteries, and nobody's been able to buy it for less than 200, and most of them are over 300. Now, these are small systems, I agree. But, the grants that we have and the projections that they have are roughly 50% of the current cost of batteries. And most of them are there. One of the benefits of this lithium ion growth is it sets a price line. When people come in and talk to me, I want to start this company or whatever, I'm saying, well, here's the price point. If you can't find a way to beat that price point, you're not going to be competitive. And this is what you got to shoot for. So when you do, now I realize we work in R&D. So, R&D is expensive. And the projects we have, they have to do monitoring, they have to do analysis. So, there's a 50% buffer that we add to a project just to give us all the stuff we ask for. And they're not going to do that in a commercial system. So it's reasonable to say commercial prices are going to come down. But, it is, like I said, we have 12, 15 different technologies, and almost all of them are predicting that they can get to that point to compete on a price basis and a value basis. Now, sometimes when you're smart, the value isn't just the out the door price, as you mentioned earlier. It's the life cycle cost or other thing. It's the safety. We have a large system in California that's not working because of a safety issue. They had to shut down and they haven't restarted yet. So those are issues that have to be addressed. Lithium ion, I tell people, you have cell phones, you have a laptop. How many here have a battery that's 5 years old? How many here has a battery that's 10 years old? Well, not too many hands come up. Now, it's the same technology. It just may be refined a little bit, but it's the same technology. So there is a huge opportunity for innovation. And what we're trying to do is spur that innovation and provide opportunities. And so we're fortunate in our environment, because when we have a solicitation, we normally award 5 to 10 grants. We don't just award 1 or 2. We have enough for multiple opportunities, and we have enough so that we're trying. And again, you have to be we're encouraging people to build in California. We pay extra money for people to manufacture in California and those type of things. So we're trying to build it in California, prove it, and then sell it all over the world. That's our desire, and to do that.
Excellent. Peter, now's your shot.
Okay, quick before somebody else cuts me in. So what I was gonna say was, was back about 15 minutes ago when we were talking about supply chain for the battery itself. You've got another problem you have to deal with, and that is interconnection process. If you're talking grid scale, you're looking at, well, first off, there's not going to be an open window next year at the ISO. You're going to have to wait till 2023. Then you've got to wait 2.5 years before you get a interconnection agreement. And then once you get your interconnection agreement, you got to wait for the utilities to build the facilities that allow you to interconnect. And that's a minimum of 18 months. So, you're looking at 5-6 years before you can interconnect that storage. So if you need it in the next couple of years, you ain't going to get grid unless you take something that's already in a queue. So new projects.
I would only say that's true if you're doing transmission level.
That's what I said.
You
Grid
mentioned
scale.
ISO.
That's what I said.
Grid scale. I mean, you
Grid
can put a 20 megawatt system on a military base or a tribe on the customer side of the meter. That's correct. If you're going to do 100 megawatts, and you're right, those projects, some of the things in the news today, you hear about Hydrostar 400 megawatts. You're right. That's a 6-8 year process.
Yeah, you can't even do 20 megawatts and expect deliverability from the ISO. Right. Even if it's behind the meter, you won't get deliverability. You may be able to connect it, but you'll be energy only at that point.
Right. It is a challenge, and even on the customer side of the meter, interconnection is one of the challenges we run into, and we work all the time with the, and of course, for the behind the meter, it's the PUC and the utilities, but interconnection of anything, particularly the bigger it gets, is challenging because you have to run these studies as to how to fix the grid and everything else. And so you are correct. These are quick projects, but I mean, in some cases, particularly military bases, universities, and tribes, there is ways you could do that at a much more accelerated. Now, you're right. You're not necessarily providing. If you're going to provide grid services on the customer side of the meter, that also is a very complex challenge.
Yep.
So, Mike, there's a question that came up. We talked about the bankruptcies. On the other side of it, you have any good success stories that things are close to becoming a commercial enterprise out of the programs that the commission has funded, or is it just too soon to tell?
No, we've had, I don't, our different office follows them as in our report, but we've had 2 companies in the last year that were startups. They started with small grants in our business, and they built components for Lithiumion, and 2 of them have just signed billion-dollar agreements. They got acquired, and as part of that, they were providing electric vehicle batteries and providing anodes and cathodes to those types of things. So components to lithium-ion batteries that are better. And so we've had several companies that have been able to, we typically speaking, the small grant program that we manage, probably 50% of the small grants are able to attract venture capital funding when they're done with the grant. And so we have a very large amount of venture capital funding that goes with these systems. It's the project financing that is the challenge we're working now, not the venture capital funding. But yes, there are some big. I gotta get my light here. This room cuts off, and then my computer will cut off. Just a second. So it's yes, we have, and I can share those. I can share those with you. If somebody's interested. If somebody made a comment by email, I'm assuming you're going to share the presentation. So my email address is on my presentation, and if anybody has questions, feel free to reach out to me, and I can share with you how to get in the queue with the Energy Commission grants and how the process works. And if you're interested, it'll come right in your email whenever they're released. And we release about 20 solicitations a year.
All right.
Great,
Well,
thank you.
I'm sure that's very helpful. Then one more thing, Mike, while we've got you on the screen here. On the long duration storage, however that ends up getting defined, it would seem to compete with things that you could do in controlling demand, controlling microgrids. How do you see that shaping up? Because what you're trying to cover with long duration storage might be covered in other ways. Do you think that is a real possibility out there? And
so there's a new
looking
phrase
at that?
coming around. There's a new phrase coming around. Zero carbon flexible resources that's out there, and so. I don't know that long duration fits in that category as much as what I'll call short duration, but there is, you get demand response, you have bioenergy projects, you have other things. So you have other things besides storage. So one of the things we are doing is looking at all the different options. I mean, when I gave a presentation today to the legislature on green hydrogen and the future for hydrogen and green hydrogen. And so the question comes down is when you look at these different options, and there are several, is coming out with what's going to provide the best product for the best value. So you can't say that any single product is going to be the home run that everybody goes after right now. But what you can say is that there are multiple choices. And at the end of the day, I do believe the price is going to make a difference. It's going to make a difference in the system. When you start talking about what I talk to the people, the public utilities company, if you're going to buy 10,000 megawatts of storage, or just say after 2030, you're going to buy 20,000 megawatts of storage. If you can buy that for 30% cheaper than you're buying for the first 10,000, that's a huge amount of money. And it's worth in nurturing these technologies to get to that point. That's what I'm trying to do, is convince the agencies that control the money, to control the utilities, to say, look, you have to think beyond today's solution, and you have to think what you can do to help in that process, to give these technologies a chance to demonstrate their capability. At the end of the day, you're going to have to perform. I mean, these are long duration means it also means you're going to be around for 20 years, in addition to operating for, 10 to 100 hours. And so if you don't perform, it ain't going to take long. That's going to be over with quick. So you have to perform, and not everybody's going to do that. But today's world is very competitive, and most people have to incrementally prove their capacity to do that. I won't mention for Garrett's benefit, but another one of the projects we awarded in 2020 was for residential storage. So we awarded 3 grants, and each grant is putting in 15 sites at three different climate zones. And in addition to putting it in and making it work, one of the things you're doing is what Garrett showed, is looking for creative tariffs that we can offer to the PUC that will allow homeowners to maximize the value of the storage that's in their garage. And so this is all part of Title 24 and what they call JA 19. And so I'm JA 12. And so the ultimate value is, we want customers to be able to provide, demand response is easy, to export is more difficult. And so looking at those different values, is how if we're going to have 10 million homes with solar on the roof and batteries in the garage, it's no different than if we're going to have 10,000 electric vehicles plugged into the grid. You have to assume them as a resource. And do you want them just to be a load, or do you want them to be part of the interactive grid? The software can do it. It's just the policies and the regulations that have to be updated.
Right. Let me toss the last question here to Garrett. I mean, obviously, great to see manufacturing coming into the Sacramento area, the systems you're building. Where are you on that curve right now? How many people do you think you're employing now, and what's your plan over the next year for the Villara systems?
Yeah, great question. Thank you for that. We have about 10 people on this team, this subsidiary of Villara Energy right now. Next year, I hope to, 3 to 5x that. And in the very near future, we're in a pretty small, what I call boutique manufacturing facility right now. And in the very near future, we're moving into a much larger facility. So that should enable us to 10 or even 50x our production capacity.
That'd be fantastic. What a nice industry for the area. So
yeah, and I mentioned before that our battery cells come from Japan, where Toshiba is based. Almost all of the rest of the components and the value-added manufacturing and assembling happens in the U.S. So we're pretty proud of that.
Well, and I mean, over time, if you get a considerable demand here, it would be common if somebody like Toshiba ends up producing a factory in the US to get the logistics out of the equation. That certainly happened on a lot of the electronics. It certainly happened in automobile manufacturers. So yeah, I for one, am not that worried about sourcing things to Japan or China when you get started, with a view in mind that ultimately you want to get the whole supply chain close to you and in the US.
Yeah, thankfully, Villara Energy feels like a somewhat scrappy startup in a lot of ways, but as a part of a much larger parent company, Villara Corporation has been doing supply chain logistics for over 70 years, and so being able to stand on the shoulders of giants has really helped us quite a bit with managing our supply chain. So we've hardly really been slowed, which is in stark contrast to a lot of other battery manufacturers.
Yeah, and kudos to Rick Wiley and all the clever things that he's done to reorient the company and grow it. It's really been a nice story. Well, we're at the end of our time here, and let's give all of our panelists and everybody who's participated a big round of applause. And gosh, it's just been a wonderful discussion. Another one that I'm sure we'll come back to in the following year because there's just so much going on. And thanks to Mark and Mike and Garrett for their participation. So over to you, Thomas, to wrap us up.
I'll wrap us up really quickly, but I do need to ask one more question. And if you each can give, a really quick, short answer on it, because we had people actually email and ask us about this one, is what are you considering or thinking about on, I know it's short for an open-ended question, battery recycling? Garrett, what are you?
That for me?
Yes, for all of
Yeah.
you.
Yeah, battery recycling is a really important consideration. Since a lot of people are motivated by trying to, be friendly to the environment. But when batteries wear out and are sort of unusable or practically unusable after 10 years, you really got to think about kind of cycling those down. And with the batteries that last 20 years, my feeling is that we have about another 10 years before we even have to begin to worry about how we're going to recycle the batteries. A lot of batteries get recycled into the home energy space, from something like the electric vehicles into home energy. So we're actually starting at home energy. So I think that our warranty is 20 years. I expect our batteries will last quite a bit longer. If I had a battery that was still at, let's say, 75% capacity after 25 years, I don't know why I would take it down. It's still providing quite a bit of value. So we're not too concerned with recycling just yet.
Mike.
And ours, we're looking at 95% recyclable. And also there's potentially a very short path for the recycling technically. So
Yeah, I'll just add real quick that we are investing in battery second use for lithium-ion batteries. I will point out, if you haven't heard this story, that in California today, 50% of the electric vehicles in the US are in California. So obviously, when it comes time to recycle, we're going to have the biggest supply. So we are doing work on both recycling and second use. It is a topic of interest to California. But again, as we look at our leading the nation in this area, we will end up in the future with the most potential. But again, as Gareth mentioned, a lot of these electric vehicle batteries, when they don't have the power you want when you press the gas pedal down, they still can operate 10, 15 years in a stationary environment. So recycling may not be necessarily breaking it apart. It may be repurposing it to a new use.
Yeah. Local company, Fox Power, has been trying to do that. I know the CEC has funded them in the past through programs, but we're going to wrap it up. I want to thank you guys for that. One of our most attended events last year was Recycling Solar. So with that, a big thank you to our guests. Thank you very much for attending, you guys, or for joining us. With that, big thank you to our guests. Thank you for making this possible and joining us. We appreciate your expertise and look forward to connecting with you in the future. If you want to watch past discussions or this ones, they will be up on our YouTube channel, and you can check out the interesting discussions around that. Additionally, if you believe in what we're doing and want to support us, we're in the midst of our fundraising campaign. We did get some donations during this, so I want to thank Laura Good for donating to us. But if you believe in what you're doing, please support us. Any amount of donation helps, and it really goes a long way in showing that you believe in what we're trying to do here of turning Sacramento and the greater region into a clean tech hub. Thank you to our sponsors, Sac State, SMUD, Wine Tribe, Tobin, and Blue Tech Valley. Thank you to our overall program sponsors of Momentum, GT Law, Penn Motion, Hacker Lab, Moss Adams, and Reverend. And I want to thank all of you for attending today. And I look forward to connecting with you in the future. And if you want to connect with any of the speakers, please do reach out to me, and I'll put also their slides in an email after this tomorrow. Thank you very much.
Great meeting. Great meeting.
Take
Thanks,
care. Thank you
Thomas.
very much. You guys have a great night.
Thanks, everyone.
Yeah. Hey, Thomas, I definitely would like to get the slides and